Hello and welcome to Rubik's Code video tutorials where we build smart apps. Bugs. Every application has some, and no matter how careful you are, you will create one sooner or later, especially if you are working on a large enterprise software. Now, I know a bunch of people that are having this "my code is clean and bugless" attitude. However, creating and maintaining bug-free code is extremely hard, if not impossible. However, that doesn't mean that, we should just give up and write spaghetti code that doesn't work. We as software developers should give our best to write high quality code. And high quality code means a low number of bugs. Apart from that, having a bug in production is extremely expensive. You're probably aware of that comparison where, finding a bug during development is 100 times cheaper than finding the same bug during production. And that is why we should focus on finding the bugs as soon as possible. Our first line of defense is testing. Now, what we could do is test our applications manually, which basically means running them, clicking around, and trying to find some bugs. Now, this approach is not optimal, and it has many pitfalls. The first one is that it is time consuming, which basically means it is expensive. The other problem is that it makes regression testing much harder. Imagine that you've added a new feature to your application, and now you want to test if all other features are not affected by this. This is again time consuming and very expensive. So, what is the solution to this? Well, of course, automated testing. Automated testing is one big topic, and in this video we will see how we can use automated tests, namely unit tests, in our development practice. We will cover topics: what are automated tests, what are unit tests, what is test-driven development, and then we will see how we can use test-driven development to solve one problem in Python. We will also see what are mock objects, and we will see what is patching. So let's go to it. As we could see, manual testing is not really working out for us, especially if we want to detect issues early during the development phase. So we decided to, automate our test. And based on the level of abstraction that the tests are done, automated tests can be separated in several categories. The first category is called unit test, and unit test is a piece of code that invokes another piece of code and checks if that output of that action is the same as desired output. Then we are having integration tests, and integration tests are similar to unit tests, but they are using one or more of outside dependencies, and they don't have full control over these dependencies. And these dependencies can be things like database, threads, or network, or something similar. Then we are having a functional test, and functional test is testing a slice or a functionality of a system, and it is observing it as a black box, and it is verifying if that feature or that part of the system is performing according to the functional specification. Finally, we are having acceptance tests or system tests, and these tests are basically observing the whole system as a black box and testing it as a whole, and they are trying to figure out if the system is fulfilling the expected business and contract requirements. This brings us to the so-called pyramid of tests, and this pyramid displays the number of tests that we should have in our application per type of tests. We can see that unit tests are at the bottom, and this means that we should have the largest number of unit tests. And for the purpose of this video, we will focus on this type of tests since they are crucial for the test-driven development process, as we will see in a little bit. Then we see that we should have less integration tests and even the lower number of functional tests, and finally, we should have some system tests. However, we should have the largest number of unit tests, which are, figuring out if our code is working well. And we will also use it, as a part of development process, which is really interesting. Now, all these definitions are a bit loose since everyone is using different names for different types of tests. For example, some people use the name developer tests, instead of unit tests, because those are the tests written by developers for developers and they can read them and understand them. However, we will not go down that rabbit hole. So the important thing to remember is that we will focus on unit tests, and you should have a lot of unit tests in your system. So as we mentioned, unit tests are testing the functionality of a unit, which brings us to a philosophical question about what exactly is a unit. And the unit is a set of actions between invocation of a method in the system and a single noticeable output of that part of the system. Now this is, equally philosophical answer, right? So yeah, the important thing to understand here is that unit test is a piece of code that tests another piece of code. And over the years, this type of test turned out to be one of the best tools for increasing software quality. And they were introduced by Kent Beck in the Smalltalk language back in the 70s, and since then they are used pretty much in any programming language. So let's see how we can use unit tests in Python. Unit tests are always written using some sort of unit test framework, and for Python that is a module unit tests. So all we have to do is essentially import this module, which comes with the Python itself, right? So I'm using Visual Studio Code here. I really like it because here I can write the code and I'm having the terminal opened right here. So I will be writing the code here and using the terminal here, down here. And all my files will be listed on the left here. Now, you can use any other IDE that you are usually using for development. Here, I will be using Visual Studio Code. So let's first create a file. We'll call it simple unittest.py. And let's import that unit test module that I mentioned before. So let's write down a unit test that can test like a simple functionality from Python. So we will test if upper function of a string really does its job. So we will test if all the letters are uppercase once this function has been applied. So in order to do that, we first need to create a test case, and test case is like a collection of test methods. And to do so, we need to create a class actually. So let's call it first test class. And this test class need to inherit unit test case, right? So this class test case from unit test module gives us a lot of possibilities. Now this is our test class, right? And within that test class we can have multiple methods, and every single of those methods is essentially one unit test. So let's create our first unit test, and as I mentioned, we will test is the upper functionality of string is working well. So I mean, we know apparently that it works well, but here we want to see how we can create unit tests. Now, unit tests are usually composed of 3 steps. In the first step, we are doing some sort of arrangement. So we are preparing our tests, or we are preparing some variables or stuff like that. Then in the second part, we are acting. So we are calling the functionality that we want to work with. And finally, we are testing, we're doing assertion. So we are asserting if the values are correct. So we're checking if the output of the code that we run is equal or not equal to some expected value. So let's first do that. Let's create a variable called test string, right? I forgot the G here, and it will be Rubik's code, right? So now, in order, this is like the arrangement part, so we will call it arrange, and then we need to do the acting. So we need to call actually the functionality that we are testing. So let's create the output variable, and we will call on the test string, we will call upper method. So yeah, here it is. We arranged our tests, we prepared the variables, and then we call the upper method, and which is the acting part. And finally, we are going to call assertion. So in order to, to check if the output is really having the value that we are expecting. And to do that, we can use a method assert equal, which we already have because we inherited this test case class. And the first parameter of this method is the output. So we will put the output of our functionality, and the second parameter is the expected value. So which will be Rubik's code all in caps, right? So once again, what we have done here, we have created a string called Rubik's code, all low letters, and then we called upper function on this string, put that result in the output, and finally we are doing the assertion here, so we are checking if the output is really all caps Rubik's code. So in order just so we can run this in an easier way, I'm just going to do this. So this unit test main will actually call all the unit tests registered within that test case, and in this one that is apparently only this test upper method, which is our only unit test that we have for right now. But yeah, that's pretty much that. So congratulations, you've just written down your first unit test in Python. And in order to run that, we just need to use Python and just call this, just pass this file, so simple unit test py. As you can see, as the output, it says that we have run one unit test, so that's this one, and that everything was okay, right? So we are having okay here. Now, if we wanted this test to fail, I will just add something here, so just so you can see how the fail test looks like. So here it says what failed and what was the difference, right? So you can see that this assertion equal failed because we are having a different string. Now, if we had more functions here, we would probably want to see for each of these functions what happened, because we would have more unit tests, right? So in order to see which tests we have run, we can use just this option. So we would put -v, and when we run it, we can see that it says that test upper passed okay, right? So everything is fine. Yeah, congratulations, this is your first unit test, and you're probably wondering, saying, all right, this is pretty simple, but what if I want to test my own functionality? So let's do that. Let's create a hello world file. And in that file, let's add a method, actually a function, just a function called getGreetings. And this function just returns hello world, right? Now, if we want to create unit test for this, I'm just going to put it in the folder here. I created it in the wrong place. So let's just create hello world tests. Okay. So in this file, let's just import unit test, and let's import from hello world. Let's import the method getGreetings from, right, import getGreetings. I hope that's a good name. I'm just gonna copy paste it just in case. All right, so let's create a class that will test if this method is returning a good value. So I'm going to create a class called hello world test, and this one will inherit the test case as well as the previous one. So here I will define a method called test get hello world, and yeah, this method will just call get greetings from the hello world and check if it is really returning the hello world string. To do so, we are again using assert equal here, but we will basically put all the steps we have done in previous unit test into one place. So we will just call get greetings, that because we don't need to put it in a separate variable, and we will check if this method, so this here we are calling it, and in the same time we are checking if that value is the same to the hello world. And yeah, we are again calling a unit main to run all the tests. So let's go to the terminal and run test hello world. So okay, I put the wrong name here, so just a second. Yeah, it was a typo. So you can see here that now when we run the test hello world and we run this test get hello world, everything was okay. In order to verify it, let's use it with the option -v, and here it is. We can see that right, we called get greetings from a different file, and yeah, we got hello world back. We checked if we got that hello world, and everything was fine. So yeah, that's pretty much that, pretty simple. Unit tests are really cool. So let's go forward. Okay, now when we know what are unit tests, and now when we know how to write them in Python, let's see what they have to do with so-called test-driven development. And let's see what test-driven development actually is. So test-driven development is an evolutionary approach to building and designing software. It is consisting of small cycles in which we are first writing a unit test that will initially fail, and then we are implementing the minimum amount of code to pass that test. After that code can be refactored to follow some good principles. Refactoring, that last part, now has a safety net because we wrote the tests beforehand. So yeah, we can reshape our solution stress-free. There are three important steps in the TDD procedures, and they are easy to remember using something that I like to call TDD mantra. It goes like this. It is red, green, refactor. Red phase is corresponding with the phase in which we are writing a unit test that will fail, so that's like a red phase. Then we are implementing the code that will make the previously written test pass, meaning it is green, right? It is a green phase. And finally, we refactor our code, and that is, we don't have really a color for that one. Yeah, so there you go. TDD mantra, red, green, refactor, and or you can observe it like this, like writing a test, then implementing it, then writing, refactoring that solution. Now, you might wonder what is the difference between just writing unit tests for your code and test-driven development. And yeah, because we are using unit tests in both cases. And the crucial difference between TDD and traditional testing is the moment in which we are writing the tests. So when we are writing code using test-driven development, we are first writing the tests and then the code itself, and not another way around. Now, before we proceed, let's examine what kind of problem we will solve in this video using test-driven development. Now, do you guys like TV show Rick and Morty, or have you seen it at all? I love it, and it is a show that follows the adventure of a cynical mad scientist Rick Sanchez and his grandson Morty Smith. Now, Rick owns a portal gun and takes Morty to a different dimension, universes and whatnot. So yeah, different versions of these characters inhabit those dimensions, and the Citadel is the place where Ricks and Mortys have formed some kind of society built by their counterparts from infinite amount of realities. Just watch the show, it's pretty cool. So here we will try to implement a couple of user stories just for fun's sake, which are defined like that, like they are coming from a Rick and Morty universe, so like Citadel for some reason hired us to do so. And here are the user stories. So the first user story is that a user is able to assign Rick's and Morty's a universe number. So that's the first one. It is going to be the most simple one. And then a user is able to add residents to the Citadel, to that imaginary city that we are having. And finally, user is able to turn all Ricks that are having assigned Mortys to pickles. For the reference for this, you should really watch the episode 3 from the season 3, right? All right, so let's see how we can do this. Okay, so let's implement the user stories that we mentioned previously. So first we are going to create a new folder here. Just give me a moment. And this one will be called solving a problem. Okay, now let's start from the first user story and work our TDD magic to the last user story. So the first user story tells us that we should have two classes, one for Rick and the other one for Morty. However, since we are using test-driven development, we first need to write unit tests and then we will implement each of these classes. So first we implement Rick test class. So here in this folder we will create a test Rick file, and so first we will import unit test module just like before, and then we will import from a file called Rick, module name Rick, we will import the class Rick, right? Now we don't have this yet, so this will actually fail, so we will not be able to import it. Also, our first user story, if you remember, is telling us that we need to assign a universe number to every Rick and Morty class, or every Rick and Morty object. So we will create a class which is called Rick tests, and as before it will implement the test case class. So let's create a method which is called test, universe, right? And in this class we will create an object, we'll call it a Rick, from the class Rick, and let's say we will assign a universe number 111 to it, and you're aware this is just our thought process. So we still don't have a Rick class, we don't have anything, so we are just writing a test that will fail. However, after we have done that, we will have like a safe net to actually run the implementation. So when we create an object from the Rick class, we are expecting it to have universe number, right? So this object, let's say, will have some sort of property or field or something which is called universe, and we are expecting it to be 111, right? So again we used assert equal just like before, and we are using all the same techniques that we have done previously. All right, so let's see what will happen when we run this. So I will run Rick test Rick py, and here we see this one fails, right? First it fails because we don't have a module named Rick, right? So let's go ahead and actually create within this folder a Rick.py file which will contain class Rick, right? Class Rick, and it's just a regular class, And yeah, let's define a constructor for this class. So yeah, we will do something like this. Yeah, so we are expecting for it to have a number which will, define the universe of that rig. So yeah, if we put self universe equals 0, let's do just that, so we can see that now we are having a test. Basically, now our test does not say, all right, this failed because you don't have a rig class. Now it detected a rig class here. However, we passed the number 111, and we are expecting that to be the value of the universe, and that is not the same, right? So let's just, whatever we are passing into constructor, whatever we are injecting, let's just give that to this field, and if we run it again, we can see that everything passed, right? So this is really cool. You can see the process here. First we write down the test, and we can see that it fails. Then we incrementally add code that will actually make that test pass. And now we could refactor this solution, but I don't know really how. It's really simple. So yeah, let's just use the same pattern that we established here for Morty class. So yeah, let's create test morty.py, and we will create pretty much the same here. So we will just from Morty module import Morty class, give it a number 111, and we expect that universe field will have that value. So yeah, when we run this, so we will now run Morty. Here, yeah, we see that we don't have a Morty class, so or Morty module at all. So let's create it, and let's create Morty class here. I will just do it like this. It's at the moment these classes are the same, but we are having different user stories. So yeah, here it is. Now we are having two classes, Morty and Rick, and these classes are doing what it's supposed to do based on the first user story. So just for you to remember, the first user story says that user is able to assign a universe number to objects of classes Rick and Morty, and that is exactly what we have done. So yeah, congratulations, we just implemented our first user story. Let's proceed to a second one and see how we can do that as well. Now this TDD dance might be, might seem a little bit unnatural at first, it's weird, right? First writing the test and then doing the implementation and having failed tests along the way. However, once you get used to it, it is really enchanting. Basically, you will wonder how you were able to do it, another way for years. Okay, so we implemented our first user story. Let's move to the second one, and this one is pretty easy as well. It says that the user is able to add residents to the Citadel. Now, Citadel should be like a separate class, and we should give, create some kind of method that is able to add different, objects from Ricks and Mortys into it, right? So yeah, let's start by writing a test to a Citadel class. So we will call it test. So now we already know that first we need to create a test class. I'm just going to move it into this folder. I've put it in the wrong folder again. So now we know that, we will have a fail test, and now we know that, we're starting by writing a test and then writing the implementation and then refactoring the solution. So also we know that we need to use unit test module from Python. So yeah, everything is pretty clear right now. So now we just need to practice and to use this technique as much as we can, and then it will, after a while it will, become natural for us. So yeah, let's now import an existing class called Citadel. Okay, so we don't have this, so just like with Ricks and Mortys before, we will, start from here, and we will create a test class which is called Citadel Test. And yeah, this one is inheriting unit test case, right? Okay, so let's create a test method which is saying test get all residents. So before we start creating like some kind of method that will, be able to receive Rick and Morty's objects, we want to create a class that will actually retrieve us what we have in the Citadel at the moment. So yeah, we want to do that. So because we want a method, because we want, to have a technique or a method or whatever to verify that our method for adding will work. So yeah, let's first create a method or tests for a method that will retrieve all residents from the Citadel class. And that looks something like this. So first we create the object from the Citadel class. We call get residents, get all residents method, which still does not exist. And then we check if the array, so we expect the array as the output of this method, is empty. Alright, here you can see those stages like arrange, act, and then assert. So let's see what happens when we run this. So we will just add, the unit test main. So here we will run test Citadel class, and yeah, since we don't have a class Citadel at all implemented yet, this test will fail. So let's create another file which is called Citadel. All right. I wrote that well, right? I did. Okay, so here we will implement a class Citadel. All right, and yeah, let's define a constructor for this one, right? Since now we already said that this we expect that this class is having some kind of property or some kind of field attribute that will contain all the residents, right? So let's do that. So let's initialize residence here, and it will be an empty array, right? So yeah, now we have an object which will contain this information within it. And if we rerun the test, we can see that now it fails because this class does not have get all residents attribute. So we need to add that method. Now, to add it, we are just going in the first iteration, because if you remember, I said that we need to implement a minimal amount of code that will make this test pass. So yeah, we will create all residents method. We'll just, it will not return anything. And you can see that here this test again fails because it returned none type, none object. So yeah, we need to actually implement this get all residents method. And to do that, we just need to return, this object, right? So that's pretty much that. So if we run it, we can see that now test passed. However, this is just the first part of the implementation, right? So we're still not able to add objects within the Citadel. So we need to add another unit test in the test Citadel file. So here we will define another method, and it is called test add residents. Now, yeah, the previous test was basically a preparation for this. So in order to do that, to test if this functionality will work, right, non-existent one, we will create an object of a citadel. We will create an object of rig class and an object of Morty class. And for that, we need to import them here, right? So I will use a snippet for that. So we need to import them. We created all the objects, and this is our like arrange part, right? Now we will call non-existent method from the citadel, which is called add resident, and here we will inject a rig object, right? And we will do the same with the Morty object here, right? And then we will, get again, do this. We will get all the residents, all right? So now we've done the act part, right? So this resident part is probably part of the assert, right? So the act part here is that we added one rig and one Morty to our citadel. And we've done this step in order to confirm that we actually have something in this in this array of residents, right? And to do so, again, we are using assert equal. Since we first added a rig object, we are expecting it to be there first, and the second object in the residence array should be a Morty object that we have added here. So if we save that, and now I'm just going to use a -v option here, so I know which test passed and which one failed, and we can see that this one failed because we don't have an add resident method here at the citadel at all. Now we can go to the citadel class and implement it, right? So in order to do so, we just need to define add resident and pass some kind of object which we'll call resident, right? That's all right. So the only thing that we need to do is use this array here and use append and add this resident object here. So if we save that, rerun it, right, we can see that now it is passed. Okay, so what we have done here is a two-step implementation. So we first created a unit test to check if to retrieve all the residents that are available in the citadel class, and then we have created a test for we created a test for functionality that should add the residents to the citadel. And then we implemented all that within the citadel class. So you can see again we used basically this dance where we first create a test, that test fails, then we go to the class and create a real implementation. Now all these methods were pretty simple, so we didn't have a need to do some kind of refactoring, but that's it so far. So we can proceed to the third user story, which is the most complicated one. Awesome, we finished 2 out of 3 user stories. However, the last one is the trickiest. This user story says that a user is able to turn all rigs with assigned Mortys to pickles, right? So this has kind of a scope creep within it, because you need to have a way to assign a Morty to a rig. So we need to handle that first, and then we can have some kind of function or method within the citadel that will turn all rigs into a pickle. I never thought I would say that word in this kind of context. So all right, let's then extend first a test class of Morty, so we can check if it is assigned or it is not assigned, right? So I'm going to use a lot of code snippets here that I already prepared. So just in order to go a little bit faster. So as I mentioned, first we have a test method that will check if a Morty is assigned. So here in this test we create an object of Morty class, and we assert if this is false, right? So we assume that a Morty class will have a field that is called is assigned, and we want it initially to be false, right? And to implement that is actually really easy. So here within this constructor, we can just add is assigned and make it be false, right? So let's run tests for Morty. Now we are having two tests. Yeah, I'm going to use a V object for that. So now we are having two tests. So we are checking if this initial is assigned is working, and it's working, and we are checking if the assigning a universe number is working, and that is working as well. All right, now we can go to Rick tests, because here we need to extend the Rick class that in a way so Morty can be assigned to Rick. And yeah, for that we need to extend the Rick class. And of course, if we are going to do a TDD, first we need to add a test. So yeah, let's do that. So we will create a test method called test has Morty. We will create a Rick object, and then we will assert if the Morty field of this class, which does not exist yet, is none. So if we run this, let's go to Rick, and we will see that test has Morty will fail because Rick has no attribute Morty, right? Okay, so let's add it, and initially this value of this, we're going to Rick class, and initially this value of this attribute will be none. So if we rerun Rick tests, we can see that they pass, right? And now we are going to the final part, where we will extend the Rick class with the method which is able to assign Morty. And to do that, of course, we first need to create a test for that, and we will go and create a test that looks like this. Let me just fix the indentation. In this test, we first create a Rick object and we create a Morty object, and for that we need to import a Morty class. All right. And then we call assign method on the Rick object. This method does not exist, so this test will fail. And then we assert if the Morty here is being the correct Morty that we've passed here as an object, injected it there. And we are also going to check if the Morty field is assigned is having this correct value. So if we run Rick tests again, we can see that it will fail because there is no assign method. So what we need to do is go to Rick class and add method there. And this method is going to be pretty straightforward. So here Morty attribute of this class will receive the injected value here, and we will switch the Morty field is assigned to true. Okay, so let's rerun Rick tests again, and now we can see that they all passed. So we kind of handled that scope creep, in which we said, all right, we need first to handle the part of assigning Mortys to Rick. So now we can go further and create pickles from Ricks, I guess, right? So the first thing here again that we need to do is actually add a test class that will check if Rick is already a pickle. So yeah, we're having a test method has basically this one tests if Rick is already a pickle, because we expect that now Rick class will have is pickle attribute, which will be true or false. Initially it will be false, right? But if I run this test, it will say that there is no attribute is pickle on the Rick class. So I'm just going there, doing again the same thing as I did before. So I need to add is pickle value here. So I'm going to do it like this. Is right, and it is false. And okay, now this was pretty simple, and yeah, now all the tests within the rig test class are passing. Okay, and now the final step is to extend the Citadel class to, call this method, basically switch this for every rig that is having assigned Morty, right? So we need to first create a test for that. Again, we are doing the whole thing, in iterations. So here we are going to add another test, which is creating an object from the Citadel class, creating an object from a rig class, from the Morty class. It is assigning this Morty to this rig object, and we add both of those residents to the Citadel. Now the Citadel does not have this function, pickle rigs with Mortys. However, we are going to extend it, and yeah, we get all residents and check if the first resident, this one, is pickle, because it should be, right? Because we assigned the Morty to it, and we added that rig into the Citadel, and then we called pickle rigs with Mortys class, and yeah, we expect that to be all right. So if we run this, we will see that there is no method for pickle rigs with Mortys, so that is what we expected. So let's just go ahead and add it into our Citadel class. Here, yeah, we will first go through all the residents within the residence array. I'm just going to change this. And then we are going to check if that resident is, type rig. So is it that an object of class rig? And then we are going to switch, its value is pickle to true, right? So again, all these methods are pretty straightforward, and they are here more to show you how to process all this. So if we run all tests, we will see that yeah, rig is not defined here, and that is my mistake, because we need to import a rig here. So if we rerun this, yeah, now we are having all the tests pass, and that is how we implemented our third, basically we implemented our third user story. And yeah, that's our final thing that we have done, we will do today. In order to truly master and fully master test-driven development, we need to know how to use mock objects. So what mock objects are? Well, in object-oriented programming, mock objects are defined basically as simulation objects. So they are mimicking the behavior of real objects in a controlled way. You might ask yourself, why would anyone do that? Well, the whole point of unit testing is isolating certain functionality and testing just that. So we are trying to remove all other dependencies. Sometimes it can be a database or a file system. So, using mock objects, we don't need to step into the world of integration testing and actually perform a unit test rather than integration test. So when can we use and when we should use mock object is when the real object is really slow, and when real object is rarely used, and it is difficult to produce it artificially, and when the real object produces some kind of non-deterministic results, or even when that object does not exist yet, and that is exactly the point when we use it with test-driven development. So let's see some examples of mocking objects and how we can create mocking objects and mock objects within Python. Okay, so the cool thing about unit test module is that essentially it is having a part or it is having a class that we can use to create mock objects. So we can just import from unit test, we can import mock, and this way we can create mock objects within our tests. So let's first create a test class, just like we have done so far, and I will just show some of the functionalities that you can do with mock objects. So yeah, we created mock object tests, and this one is using this test case class. It is inheriting it. So yeah, let's see how we can use this mock class to mock any function, variable, or object. So check out this test. So I'm sorry, I will just need to align it well. So here in this test, we first created an object of a mock class, and then we use this assert keyword to check if this is a mock object. And you can see that I used things like field1 and field2, and basically you can define and access any field of a mock object, which will return another object of mock class. And apart from that, you can observe this object as a function as well. This means that you can call it like this, and again it will return some kind of mock class. So yeah, this is pretty straightforward. So if we run this, I just need to call it mock object, you will see that oh, I didn't save it, sorry. So if I add a main, of course, here, save it and run it, you can see that this test pass, which is what we expected, because we see that mock object can basically, you can define any attribute within it, you can observe it as a function, and everything, every functionality is basically returning another mock object. So yeah, in order to control it more, you can use configure mock function. So for example, what we can do with mock objects is here we can create, again, what we have done in this test. We basically create a mock object, we assign, we created a field which will have some kind of code value, and when you assert it, you will see that it works well. The other way to configure field or method or anything from a mock object is using this configure mock method of it. So here what we did is basically we used that method and said that this object M has a field TDD which has value rules, right? So if I again run this, I will see that my two tests have passed. I will use a V option just to be more transparent. Now, of course, you can configure fields like this using configure mock, but the other thing that you can do is mock methods or functions as well. So if we create another test which says test function, and we create again an object of a mock class, and we create get11 and says that return value equals to 11, then this get11 is actually a method of a mock object. So if we check it and if we actually call it as a function, you will see that this returns a good value. So let's do that, and yeah, I didn't save it, sorry. So once I save it, I can see that all my 3 tests passed. So here within this 3 test, you can actually see that we can observe this mock as a class which has its own fields, it has its own functions, its own methods. So we can configure them using either this configure mock method, or we can use this return value if we want to mock a method, right? Now we also can, this is like a happy path where our function is returning some value, but sometimes we want to test non-happy paths. So what if we want to test the method that we want to to throw an exception? So here is how we can do it. So we can even test our non-happy paths by just using this throw exception side effect, and then throw whichever exception that we want. This side effect option is actually a really important feature, and you can do other things with it too. If you want, you can return a different value on each call of this method, or basically any method. So how to do that? Well, it is pretty straightforward. So here we are again in this test, we are creating a mock object, and we say again we are having a method which returns value 11. However, if we say this get11 side effects are having basically, and we say side effects are that on a second, on third, and on a fourth call, it will return values 12, 13, and 14 respectively. So we can call assert equal and check if those values are really correct. So here, if we run this, we can see that multiple return also passed, because first time we call it, it returned value 12, the second time it returned value 13, and finally it returned value 14. Using mock class, we can verify that some method has been called, is some method called at all, or was it not called? Sometimes that's the only way that we can test some methods. So for example, we want to inject something into some class, and we want to check if the method was called, right? So if a method of that object was called. So how to do that? We can create a mock object, again use this called function, right? And so here we created actually a called function which returns value 11. We called it, and then we use assert called, which is checking if this method has been called at all or it wasn't, right? In fact, we can check if this method was called only once, or we can check if this method was called multiple times. So here we can use method assert called once, or we can use this assert equal and called function called count. Actually, it is a field within this method, and yeah, we can check if it's been called 3 times, and here it has been called 3 times. So that's another functionality that we can do. Of course, in the end, we can restart mock object, so it can pass different values as well, right? So we can restart it and say, okay, I've done some configuration, I've done something like that, I've called some functions multiple times, but I want to reset it, and I want to do this configuration from the beginning. So by using this reset mock, you can see that here that call count has been returned to 0. So that's it. Those are the options that you can use with mock objects. When you create a mock object like this, you can inject it in any class. So for example, we could use mock objects with Morty and Rick in the previous examples. Like create a mock object for Morty and inject it within Rick, and then check what happens. And yeah, that's how we create separate, and that is how we isolate the functionalities and test just them. So there you have it. Now you know how to use test-driven development with Python. In this video we are giving a free guide, Python for Data Science, which you can get if you subscribe to this channel and leave in the comments favorite song from the band whose t-shirt I'm wearing. So yeah, let's do it. Also, check out Ultimate Guide to Machine Learning with Python, which is our bundle of ebooks and guides that can help you become machine learning superhero. It is crafted for beginners, so you will learn everything from Python basics to how to build machine learning algorithms, and how to build and maintain and deploy neural networks. So it is all in one package, so make sure you check it out if you're interested in machine learning. So yeah, thank you for watching and see you next time.